Hello friend, myself Professor HK. Today we learn new topic angle of contact. In this topic we can discuss firstly definition of a angle of contact, then we can discuss characteristic of angle of contact and another one shape of meniscus. These all things we can discuss here one by one sequentially. Firstly we discuss angle of contact. Definition: for a liquid in a contact with a solid, angle between surface of solid and a tangent drawn to the free surface of a liquid of the point of contact measured from the side of liquid is called angle of contact of that solid liquid pair. Repeat again this definition. For liquid in contact with solid, angle between surface of solid and tangent drawn to the free surface of a liquid of the point of contact measured from the side of liquid is called angle of contact of that solid liquid pair. This definition we can explain here in diagram. Here two diagram: angle of contact between water and glass. Here we consider here tangent to the solid surface. Tangent to the solid surface is AP here. Tangent to the solid surface is AP here. And AT tangent to the liquid surfaces. Here is a liquid surface. Here angle of contact between water and glass here. AT tangent to the liquid surfaces here. This capital A sphere of influence of molecule and theta with the angle of contact. We can measure this angle of contact. We consider here tangent drawn to the free surface of a liquid, of point of contact. This point of contact here, measure from the side of a liquid. We can measure this angle in this side, and this is the angle of contact. Similarly, here we can write angle of contact, tangent drawn to the free surface of a liquid. This is the free surface of a liquid. Free surface of a liquid here. An angle measure we can here in this way. The angle between mercury and glass is obtuse, and here angle of contact between water and glass is a acute angle. In this way we can discuss a definition of a angle of contact. Then we discuss here characteristic of a angle of contact. First characteristic: for a given solid liquid pair, the angle of contact is constant. For given solid liquid pair, the angle of contact is constant. Second characteristic: the value of angle of contact depend upon nature of liquid and solid in contact. The value of angle of contact depend upon nature of liquid and solid in a contact. Third characteristic: the angle of contact depend on the medium which exists above the free surface of a liquid. The angle of contact depend on the medium which exists above the free liquid surface. And fourth characteristic, the angle of contact changes due to added impurity. We can add impurity, then angle of contact is changes here. And last one, last characteristic, the angle of contact changes due to change in temperature. If temperature changes, the angle of contact also changes. So, question asked on this topic, state the characteristic of angle of contact. And first one is the defined angle of contact. State the characteristic of angle of contact. Then we can discuss next point is a shape of meniscus. Shape of meniscus. In this point we can discuss four cases or four points. First is a concave meniscus. Concave meniscus. Here angle of contact is a acute angle. Second case, convex meniscus. Angle of contact is a obtuse. And next one, zero angle of contact. And fourth one, angle of contact 90 and condition for convexity and concavity. These four cases we can discuss shape of meniscus with the help of molecular theory. Firstly, see this diagram. The phenomena of angle of contact can be explained on the basis of molecular theory. Consider a molecule, capital A here. This is a molecule, capital A, of liquid in contact with a solid. Draw the sphere of influence. We can draw here sphere of influence. It partially in liquid, partly in solid, and partly in air. Partly in solid, partly in air, partly in liquid. That time following forces act on molecule A here. First force, adhesive force. First force, adhesive force. Adhesive force exerted by the molecule of solid. This force is here solid. Adhesive force exerted by molecule of a solid. By symmetry, the resultant adhesive force is perpendicular to the surface of the solid and it is represented by AP. This adhesive force represented by here AP. AP bar. Next one, cohesive force exerted by the molecule of liquid. Cohesive force exerted by the molecule of liquid. By the symmetry, the resultant cohesive force is inclined at angle of 45 degree. Here angle is 45 degree from the solid surface. Here solid surface, it is represented by EQ. Angle is 45 and this cohesive force is represented by EQ denoted by F suffix C. Adhesive force exerted by the molecule of air as the member of air molecule in the sphere of influence is very small, the resultant adhesive force due to air molecule can be neglected. And fourth force, capital A, is also acted upon by gravitational force equal to its weight acting vertically downward. This force is also very small compared to the strong adhesive and cohesive forces. Therefore, this force also can be neglected. The behavior of molecular depend only on AP bar, AP bar here, AP bar and AQ bar. In the state of equilibrium, the free surface of a liquid is always normal to the resultant force acting on it. First case, concave meniscus angle of contact is acute. In this case, we can see in this diagram, in case of liquid which partially weights the solid, for example is kerosene. The resultant adhesive force AP, this is the resultant adhesive force AP, is strong than the resultant cohesive force AQ. This force AQ. Therefore, resultant A suffix, therefore resultant AR lie inside the solid. In equilibrium, the tangent AT, this tangent AT to the liquid surface must be perpendicular to the resultant force, that is AR. Therefore, liquid molecule capital A move upward and a liquid surface become concave. Liquid surface become concave. Here, liquid surface become concave, forming an acute angle of a contact. This is the first case. In second case, case second, concave meniscus angle of contact is obtuse. In this case, liquid which does not weight the solid, for example mercury, the resultant adhesive force AP on molecule A is small. See this diagram. Liquid which does not weight the solid here. See this diagram. The resultant cohesive force AQ, here is a resultant cohesive force AQ on molecule A, therefore the resultant force AR is inside the liquid. The equilibrium, the tangent AT, here is a tangent AT, is perpendicular to the AR, here. Therefore, molecule A move downward, and the liquid surface become convex, forming an obtuse angle. Here angle is contact is here obtuse. And third case zero angle of contact in case of liquid which completely wets the solid. For example, pure water, the resultant adhesive force AP bar is very strong than the resultant cohesive force AQ. See this diagram. See this diagram. In case of liquid which completely wets the solid, for example pure water, the resultant adhesive force AP bar is very strong than the resultant cohesive force AQ bar. Therefore the force AQ can be neglected here, and the resultant AR, you can consider here resultant AR will be in the direction on AP, will be in direction of AP. Therefore the liquid surface in contact is almost tangential to the solid surface and the angle of contact is 0 here. We can given here angle of contact is 0 here. And fourth case angle of contact 90 degree and condition for convexity and concavity. See this diagram. Consider a hypothetical liquid having angle of contact is a 90 degree, here 90 degree, with a solid container. The molecule experience both adhesive and cohesive force since the wall is vertical. The molecule acted upon by the net adhesive force exerted horizontally by the AP molecule of solid AP, as this force is a F suffix A, that is a adhesive force. Net cohesive force exerted at nearly 45 degree to the either of molecule of the liquid AQ. Here another force AQ adds F suffix C, that is a cohesive force. The net cohesive force F suffix C is exactly at 45 degree either of the surface, and the resultant force F suffix R is exactly vertical along the solid surface. Is F suffix R exactly vertical along the solid surface. For this to occur here, for this occur, F suffix A is equal to F suffix C upon square root of 2, where this condition AR is equal to F suffix R is the magnitude of net force. From this we can conclude that for acute angle of contact, F suffix A greater than F suffix C upon square root of 2, and another condition for obtuse angle of contact, F suffix A less than f suffix c upon square root of 2. In this way, we can complete shape of meniscus. Some question asked on this topic. First one, draw label diagram to show angle of contact between first one pure water and clean glass, second one mercury and clean glass. Next, another question, for a solid liquid interaction derive the condition for acute and obtuse angle of a contact. In this way, we can complete this topic: angle of contact, definition, characteristic of a angle of contact, and then shape of meniscus. Today we stop here. Thank you.